This video briefly reviews proofs in SL and shows how all the same rules and structure still apply in QL. Before starting in on proofs in QL, let's quickly review how proofs work in SL. In a proof, every line is either an assumption or follows from earlier lines by one of the rules. Structurally, we start with the premises, the given sentences, if there are any, then we draw a horizontal line, and everything after that follows by a rule. We write down more sentences until we're able to write down the conclusion, the sentence that we're supposed to prove. We can also start a subproof, which is a proof within the proof. The subproof gets one sentence as an assumption, and everything else in the subproof has to be justified by a rule. After we end the subproof, we can apply one of these rules: conditional introduction, biconditional introduction, negation introduction, or negation elimination. The point is, the only thing we can do with a subproof is apply one of these specific rules, because these rules make use of a subproof. But once we've ended the subproof, once we've closed the subproof, we can't do anything with the lines inside it anymore. We can also give proofs without any premises at all. And then the conclusion, the last sentence, is called a theorem. Proving a theorem always requires a subproof, because we need something to work with at the top of the proof. Okay, so the core of the proof system for SL is the basic rules. There's a reiteration rule, and for each connective, an introduction rule and an elimination rule. We also have a bunch of derived and replacement rules. They don't allow us to prove anything that we couldn't prove with just the basic rules, but they take fewer steps to do it. They're like shortcuts that we allow in our proof system to make our lives easier. The good news is, all of that still holds for proofs in QL. If there are no quantifiers, then everything works just like a proof in SL. For example, consider this. We're asked to show that given PA or MA arrow SA, we can prove not SA arrow not PA. We set up the problem in the usual way by writing down the given sentence on line 1. There's not much we can do with that on its own. We might want to use conditional elimination, the arrow elimination rule, but if you look at the form of that rule, it requires two lines. We need a conditional, but we also need the antecedent of the conditional somewhere on its own line. So there's not really much we can do working forward from line 1. So we consider where we need to end up. Not SA, arrow, not PA. It's a conditional, so a natural thought is to use conditional introduction on that last line. So that's the arrow I rule. And if you take a look at that rule, it requires a subproof. In the subproof, we assume not SA, and we try to prove not PA. Then back out in the main proof, we can use conditional introduction to get not SA, arrow, not PA. So once we've decided on this as a strategy, we have more to work with up at the top. We have lines 1 and 2 now. And our immediate goal is a little bit different. What we're trying to do is get not PA in the subproof. There are a number of ways we could go from here, but here's one way. Looking at lines 1 and 2, you might notice that they fit the pattern of one of our derived rules. They fit the pattern for modus tollens. We have a conditional on line 1, we have the negation of the consequent, we can write down the negation of the antecedent. That is, we get to write down not PA or MA by modus tollens applied to lines 1 and 2. So as a next move, we look at line 3, and this is another pattern. There's a negated disjunction. That's the pattern for De Morgan's rule. De Morgan's rule lets us take a negated disjunction and end up with a conjunction of negations. That is, we take the negation from the outside, move it to the inside so that it applies to both conjuncts, and the or becomes an and. So it's not PA and not MA by De Morgan's rule applied to line 3. Now, remember, we want to end up with not PA, and we can get that now by and elimination applied to line 4. So that's what we wanted in this subproof, so we can close the subproof and fill out the last line. It turns out it's line 6, and the conditional introduction is applied to lines 2 through 5. This is just the kind of proof that we might have done in SL, but it's in QL. The point is, all of the same rules and strategies that we saw with proofs in SL are still going to apply now. Of course, we're going to want to be able to reason with quantifiers, and to do that, we'll need some new rules. The proof system for QL will take the proof system for SL and add 4 new basic rules, an introduction and an elimination rule for each quantifier. We'll also have one new replacement rule, QN, which stands for quantifier negation. We'll introduce those new rules over the course of several videos.